Today's notes are brought to you by music, and our title is 8-6 Law of Cosines. You will need your trig table, so make sure you have that available. Our title is 8-6 Law of Sines. We are going to, again, look at why the law of cosines works. I'll write out the law of cosines, and we're going to have 3 examples, 1, 2, and 3. So why does the law of cosines work? The first thing you need to do is to copy down the same triangle that we looked at when we looked at the law of sines. Again, we're going to look at the relationship between the triangles in here, but this time we're going to come up with a relationship that involves cosines. This one's a little bit more complicated, and I do want you to copy this down. So the first thing we need to do is break apart those 2 triangles. And I want you to notice that when I look at this triangle, just this triangle, I can say that x squared plus h squared equals b squared. That's the Pythagorean theorem. And if I was going to look at the cosine of the angle A, that would be adjacent over hypotenuse. I would get x over b. So those are just 2 things that I realized from this triangle. Now if I use the Pythagorean theorem on the other half of this triangle, the hypotenuse squared would equal the 2 legs squared added together. Now, before I do anything, I did want to do a little bit of calculations with this one right here. And I just want to point out that if you multiply by b on both sides, you would get b times the cosine of a equals x. So I have 2 things that I know for sure right here, given the other triangle. I'm going to go ahead and do the Pythagorean theorem, and I get a squared equals h squared plus, I'm going to multiply this out to get c squared minus 2cx plus x squared. Now I know it's hard to see this, but I want you to notice that there's an h squared plus x squared. H squared plus x squared, well, there's a value for that right over here. X squared plus h squared is b squared. So I'm going to go ahead and say that a squared equals b squared plus c squared. Okay, the b squared came from taking the h squared and the x squared and substituting it for b squared. Now, this is a stretch, so stay with me. I'm going to keep the minus, the 2, and the c, but instead of writing x, I'm going to substitute x with a cosine of a times b. So I'll put that in. That's b times the cosine of a. Now, let me remind you what we just did here. We took this original triangle and we looked at different properties involving the 2 triangles, and we were able to come up with something that's true, that a squared, this opposite side, is equal to b squared plus c squared minus a combination of 2 times those 2 sides and the cosine of angle A. And that's actually the law of cosines. Let me show you where all the variations of it on the next slide. So here's the actual law of sines. It says for any triangle ABC, the law of cosine relates the cosine of each angle to the side lengths of the triangle. Now these are the specifics. These are all the different ways that you can write the law of cosine. I do want you to copy these down. You don't have to color code it, but you do need to have this triangle, and I'm just going to go over one of these. Let's say you wanted to know the length of this side. It would be equal to the other 2 sides squared added together minus twice those 2 sides times the cosine of the angle across from that side. So let's try using the law of cosines. What I did first is copy down one of the law of cosines, and the directions say use the law of cosines to find the missing side length round to the nearest hundredth. I'm going to go ahead and call the missing side A. And I'm going to fill in those values right now, knowing that I have a side B and a side C. Okay, given that, I'm going to plug in my values, and I know that A squared is equal to my B value squared plus my C value squared minus twice those values multiplied together times the cosine of the angle across from that side A, which is 36 degrees. Now I know you're thinking to yourself, oh my gosh, I have to round to the nearest hundredth. Well, let's do the math we know. I know that 4 squared is 16. I know that 7 squared is 49. And I know that 4 times 7 is 28, and twice that is 56. And I actually already know the cosine of 36 also. When I look it up in my trig table, it's 0.809. And I can prove that to you right now. The cosine of 36 degrees is right there. Now notice that's 0.8090, and I didn't include that. Okay, I can continue with my math here. I happen to know that 16 plus 49 is 65, and 56 times 0.809 is 45.304. Now when you take 65 and you subtract 45.304, you're going to have to put in some zeros there. And when you subtract it, a squared is 19.696. Now there's no way that you know the square root of this, so your answer, no worries about finding it to the nearest hundredth. You're just going to say a is equal to the square root of 19.696. And this is actually where you're going to stop. Let's try the law of cosines again. The first thing I did is I copied down my law of cosine, and I read the directions. It says use the law of cosines to find the missing side length, round to the nearest hundredth. You and I know that we're going to not leave it to the nearest hundredth. Just kind of an example of what you might do in your homework. Now the first thing I noticed is this missing side is called x. So even though they called it x, I'm going to erase it, and I'm going to call it a, so that it's really clear that that's my a side. My pen is too fat. Let me make it skinnier. There we go. Here's my b, and I'm just choosing random sides to be b and c. Those ones kind of don't matter. But of course, a is always my missing side. Okay, so this is what I have so far. So b is 2, c is 5, and a is unknown. So when I fill in my values, I have a squared equals 2 squared plus 5 squared minus twice my sides multiplied together times the cosine of angle A, which is the angle across from that side, which is 40 degrees. Okay, let's do the math we know. 2 squared is 4. 5 squared is 25. Twice 2 times 5 is 20. And the cosine of 40 is 0.766. And of course, you're going to find that in your trig table. Now, I'm going to actually stop here, and I'm just going to ask you to finish with a equaling the square root of a number. I'll give you a little bit of guidance. You're going to want to add these values first, multiply these second, then you're going to subtract, and lastly square root. So add, multiply, and square root. So good luck on that, and of course I'll be checking to see all of your math work in here when I check your notes. Okay, for example 3, they're changing it up a little bit. The directions say use the law of cosines to find the missing angle. Before they were asking us for missing side, now a missing angle, and that's going to change our strategy a little bit. The first thing you should notice is they have given us 3 sides, and the angle they're asking us to find is angle y. The side across from it is 9. That means that's our A. Our B can be either the 8 or the 5. I just decided that. And I'm going to choose for my C to be 5. Now when you plug in your values, the strategy is going to become a little clearer. A squared is 9 squared. My B value is 8. My C value is 5. My B is 8. And my C is 5. And this time my unknown is the angle A. Now if we do the math that we know, 9 squared is 81, 8 squared is 64, 5 squared is 25, and 8 times 5 is 40, twice that is 80, times the cosine of A. Now again, order of operations is going to get us to isolating the cosine of A. So I'm going to start off by adding 64 and 25. When I do that, I get 81 equals 89 minus 80 times the cosine of A. I'm going to move this up a little bit. I want you to imagine for a second that this is 5 equals 6 minus 2x. If you were going to solve for x, you obviously would subtract 6 from both sides. And that's what we're going to do. We're going to subtract 89 from both sides, and we get negative 8 equals negative 80 times the cosine of a. From here, I would divide by negative 80 on both sides, and you get 8 divided by, I ran out of space, 8 divided by 80 equaling the cosine of a. Now, my question now is, can I move this over a little bit? There we go. Can I find a cosine in here that will equal the same amount as 8 divided by 80? Now, if I do the division, I actually get 0.1. So which angle will give me the cosine equaling 1, or the closest to 1? So if I zoom in here, here's my cosine. Now all of these are 0.1, but I would say the closest is this one right here, which is 84 degrees. That means that my angle A is 84 degrees. And if I have to make any comment about any of these three law of cosines, I would say this question is my favorite.